Hi, I'm Bob. Welcome back to the solutions to the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition. We will address the problems of the group price discrimination in Chapter 12. Let's find answers to exercise 3.1. A monopoly has a marginal cost of 0 and faces two groups of consumers. At first, the monopoly could not prevent resales, so it maximized its profit by charging everyone the same price, P equals $5. No one from the first group chose to purchase. Now the monopoly can prevent resale, so it decides to price discriminate. Will total output expand? Why or why not? What happens to profit and consumer surplus? We can draw a graph similar to that of the solved problem 12.1. For a zero marginal cost monopoly, it sells its products to both groups of consumers in the single pricing case, as panel C shows. It maximizes its profit in this way. If this is the case, the total output could be equal to the group price discrimination case. The graph in solved problem 12.1 in the textbook clearly shows this result. The monopoly's profit will increase, and the consumer surplus will decrease after the group price discrimination. You can verify this conclusion using the textbook example. If the monopoly chooses not to maximize its profit by only selling its products to Group B in the single pricing case, then its output will expand when it can group price discriminate. Let's solve exercise 3.2. A firm charges different prices to two groups. Would the firm ever operate where it was suffering a loss from its sales to the low price group? Explain. No. If the monopoly can group price discriminate, it sets different prices for different groups of consumers, maximizing its profit in the market for each group. It will not sell products to the low price group if it is suffering a loss. Let's find answers to exercise 3.3. A monopoly sells in two countries, and resale between the countries is impossible. The demand curves in the two countries are as follows. The monopoly's marginal cost is 30. Solve for the equilibrium price in each country. The monopoly can divide its consumers into two groups. It chooses quantities Q1 star and Q2 star to maximize its total profits. We obtain the first-order conditions by partially differentiating profit pi with respect to Q1 and Q2 and setting these partial derivatives equal to 0. Then we have the profit maximization condition for group price discrimination. Marginal revenue for each group equals each other and equals the marginal cost. For this exercise, we can write down the marginal revenue function directly for each group of consumers. We solve for the optimal quantity in each country, 35 and 22.5. Substituting them into the demand functions gives the monopoly optimum prices in the two countries, 65 and 75. Let's go to exercise 3.4. The monopoly sells tickets at the gate and at local municipal offices to two groups of people. Suppose that the demand function for people who purchase tickets at the gate is QG equals 10,000 minus 100 times PG, and that the demand function for people who purchase tickets at municipal offices is QM equals 9,000 minus 100 times PM. The marginal cost of each patron is 5. In Part A, if the monopoly cannot successfully segment two markets, what are the profit maximizing price and quantity? What is its maximum possible profit? The uniform pricing monopoly maximizes its profit by setting marginal revenue equal to the marginal cost at the optimal quantity. We need to derive the combined inverse demand function and the corresponding marginal revenue function. The total demand is the horizontal sum of the individual demand for the two groups of consumers. So, the inverse total demand function is as follows. If the price is between 90 and 100, it is P equals 100 minus 1 over 100 times Q. If the price is less than 90, it is P equals 95 minus 1 over 200 times Q. We then write down the corresponding marginal revenue function. The total marginal revenue curve has a kink at the price of 90 as the total inverse demand curve. We can solve for the single price monopoly solution. It maximizes its profit where its marginal revenue equals its marginal cost. The profit maximizing output is 9,000. Substituting the quantity into the inverse total demand function gives the monopoly price of 50. The profit is the producer surplus if there's no fixed cost. It equals 405,000. In Part B, if the people who purchase tickets at one location would never consider purchasing them at the other, and the monopoly can successfully price discriminate, what are the profit maximizing price and quantity? What is its maximum possible profit? If the monopoly can group price discriminate, it maximizes its profit in each market. Setting the marginal revenue equal to the marginal cost for each group, we can obtain the optimal output and price for each group. The maximum possible profit when there is no fixed cost is 406,250. It is larger than that in the uniform pricing monopoly case. Let's do exercise 3.5. The estimated Tesla demand functions are as follows in the United States and Europe, as figure 12.3 illustrates. Using that and other information from the application Tesla price discrimination, confirm that Tesla's profit-maximizing prices and quantities are those in Figure 12.3. Suppose Tesla can group price discriminate. It maximizes its total profit by setting its marginal revenue equal to its marginal cost at each market. In the US market, we can write the inverse demand function from the demand function. We then directly write the marginal revenue function from the linear inverse demand function. The first-order condition for profit maximum gives the quantity of 30 and the price of 80, the same as those in the textbook. Similarly, we can verify Tesla's profit-maximizing output and price in the European market. Thank you so much for watching this video and solving the exercises with me. See you soon. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.